Hello, welcome back. We are going to go through some of these practice problems just so that we know how to expand and condense them. So let's go ahead and go through this. Use the product rule to expand each logarithm. So I've got log base 6 of 7 times 11. So if I wanted to expand this out, I would write it as log base 6 of 7 plus log base 6 of 11. Okay, and that's all I'm doing. Okay, we're just expanding that out. All right. On the next one, what we want to do, same thing here. Now, this one, when you have 100x, remember you're multiplying 100 times x. So this is log of 100 times x. So if I wanted to expand this out, I would write this as log of 100 plus log of x. Now, on this one, this is where it gets a little tricky because on some of these problems, you can evaluate this, all right? So if you think about it, if there is no base, we assume that it's 10. So log base 10 of 100, okay, plus log base 10 of x. Okay, now if I look at log base 10 of 100, really what I'm looking at is 10 to the what power gives me 100. Okay, and I can evaluate that. Remember, when we write a log, we're really just solving for this exponent here. And that exponent would be 2. So if I wanted to really write this out, if I can evaluate a log, I'm going to. All right, so 2 plus log base 10 of x is what we get. Okay, and we're just expanding that out. All right, so these are equivalent statements, all right, when we write this out. All right, let's take a look over here. Log base 8 of 23 over x, because we are dividing them. Okay, dividing what's inside of my logarithm, we want to subtract. So this is going to be log base 8 of 23 minus log base 8 of x. And that's it. Okay. All right. Here, natural log, same thing. Now, the other thing I can do is I can do the natural log of e to the 5th, okay, minus the natural log of 11. Now, we're not done, okay? Remember, I can take this 5 and I can bring that out front and I can multiply. So I can do 5 times the natural log of e minus the natural log of 11. Now, we can still continue this because we can evaluate the natural log of e. So let's talk about that, all right? So the natural log of e, okay, so remember this is log base e of e, all right? And if I wanted to put that into exponential form, I would say e to the what power gives me e, okay? Remember, e is a number. It's like pi. So e to the what power gives me e. That would give me a value of 1, okay? So the natural log of e is always equal to 1, okay? This is always the case, all right? And so that's what we got there. So natural log of e. So I've got 5 times 1 minus the natural log of 11. Okay, and that's just going to give me 5 minus the natural log of 11. All right, so we got to be able to expand those out. Okay, all right. Now we already did use the power rule on this one. Okay, and so that was kind of one where we didn't necessarily. Let's just, if we can use the power rule, let's go ahead and do it. If you left it like this, I suppose that's okay, or like this, but I really do want you guys to evaluate that. So, all right, let's go down through here. So now what we've got here is I'm going to expand out this logarithm, okay, expand each logarithm expression, okay, and so what I've got here is I'm going to get 9 times log base 6 of 3, okay? And that's what I would do to bring that out, okay? Now, on this one, you may, think that, 6 to the what power gives you 3, and this you can't evaluate, so we're just going to leave it like this, okay? On this next one, okay, natural log of the cube root of x. Now, remember, the cube root of x can be rewritten as x to the 1/3 power, okay? And so when I have that, I'm going to bring my 1/3 out front, and so I've got 1/3 times the natural log of x. And we just leave it like that, okay? On part C, okay, we have an exponent of 2. So bring your 2, bring it out front. So 2 times log of x plus 4. And that's it. That's all we're dealing with, okay? All right, let's take a look over here. Now, we want to expand each expression as much as possible, okay? So a couple things here. Let me rewrite this. This is log base b, all right? And these are kind of involved. So log base b of x to the 4th times, and let's rewrite this as y to the 1/3 power. Now, the first thing I want to do is expand these out because I've got, multiplying these two things here. So we want to expand it out using, the product rule. So log base b of x to the 4th plus log base b of y to the 1/3. Now, I'm going to take my 4 here, and I'm going to bring that out front and multiply. So I've got 4 times log base b of x. And then same thing with this 1/3. I'm going to bring that out front and multiply. So I've got plus 1/3 log base b of y. Okay? And that's what we've got. And that's as far as we can go. Okay? We can't evaluate anything, but if we can't evaluate anything, we will try. Okay? All right. On this one, okay, let's do this. Let's do... all right, let's write this as log base 5 of x to the 1/2 power divided by 25 times y cubed. Now, this is where it gets a little weird, okay? And so what I want to do is first do, I usually try and group my denominators or numerators, okay? And watch what I'm going to do here. So I'm going to do log base 5 of x to the 1/2 minus log base 5 of 25, and let's do times y cubed, okay? So now we've done this first initial expansion, okay, where I've done, my numerator and my denominator, okay, and subtracted the two. Now what I'm going to do is I'm going to separate this out. Now when I do that, because this is a group, okay, log base 5 of x to the 1/2 minus, I'm going to put a parenthesis around this, and I'm going to do log base 5 of 25 plus log base 5 of y cubed, okay, and put a parenthesis around that. Now what I can do is I can bring out my 1/2, okay, up here, bring that out front. Okay, so I can get 1/2 times log base 5 of x, and then minus, now this part here, log base 5 of 25. Now remember, all right, we can evaluate that. 5 to the what power gives us 25, okay, and that's going to be 2, okay. So I'm going to replace this with 2, all right, plus, okay, and then I'm going to bring out my 3 here, and we get 3 times log base 5 of y, okay? Now, I would just keep it like this, okay? And you can, theoretically distribute this negative, but I try not to, merely for the case of, I like to kind of keep things, grouped as they are, okay? If we needed to distribute that negative, sometimes you do need to do that, but that's not always the case. But if you need to, then let's go ahead and do that. All right. All right, that's all I got for this page. Let's go on to the next one. Okay, so on this one, we want to write it as a single logarithm. Now, this is going to be a pretty crucial thing for us to do when we are solving logarithmic equations. So because I'm adding these two logs, I'm going to multiply what's inside. So I'm going to rewrite this. I'm going to zoom in just a little bit further. Log of 25 times 4. Okay, now I want to multiply these two numbers together if I can. Okay, if you can't, then let's not worry about it. But this is going to give me log of 100. Okay, now remember, if there is no base, we assume it to be 10. So this is log base 10 of 100, and that begs the question, 10 to the what power gives me 100, and that's going to give me 2. Okay, so if you write it as a single log, which is great, but try to evaluate it and get 2. Okay? All right, over here, on this guy, log of 7x plus 6 minus log of x. So I'm just going to write it as a single log. Because I'm subtracting, I want to divide what's on the inside. So 7x plus 6 divided by x, and that's it. Okay, can't go any further with that. All right. Take a look at the next one. Okay, right is a single logarithm. All right. First thing I'm going to do is do the opposite of the power rule. So I've got my 2 here and my 1/3 here. So I'm going to do rewrite this as the natural log of x squared. Okay, plus the natural log of x plus 5 to the 1/3 power. Okay, now let's continue that. Let's rewrite that as the cube root. So this is natural log of x squared plus the natural log of the cube root of x plus 5. Okay, now because I'm adding my 2 natural logs, okay, we can write this as a single logarithm. So natural log of x squared times the cube root of x plus 5. And that is it. All right. And so that's what we've got going. All right. So there was that one. Let's take a look at this guy here. Let's do the opposite of the power rule first. So let's bring that 2 up. So we've got log of x minus 3 squared minus log of x. Okay. So now, because I'm subtracting them, I want to divide what's on the inside, so log of x minus 3 squared divided by x. And that is mine. You can put parentheses around that if you want, but you don't have to. Okay, so that's what I got there. Let's take a look at this guy. These two get a little involved, okay? Now, here's where it gets a little tricky, okay? Let's do the opposite of, let's bring our... do the opposite of the power rule. Let's bring those numbers up first. So I've got log base b of x to the 1/4 minus log base b of 5 squared, okay, minus log base b of y to the 10th, okay. Now from here, what I want to do is think about, think about this group here. Okay, when I've got repeated subtraction within a logarithmic expression, what I want to do is factor out a negative, okay? And watch what I do here, and this is going to be really important because I'm going to do log base b of x to the 1/4 minus the quantity log base b of 5 squared plus log base b of y to the 10th. Okay, this is 5 squared. Maybe I said something else. This is 5 squared. Okay, and why I did this is because this is going to help me group things. Okay, if I can distribute my negative back in here, and it would give me back what I had up here. Okay, and this is where it gets a little tricky. Remember how we stopped here on the last page? We could have continued on and distributed that negative, and we would have gotten two negative values here. Okay, but what I want you to think about is when you have these two negatives, you're dividing these, and then you're going to divide that again. Okay, so that does get a little tricky. My advice is to, if you have repeated subtraction, try and group those together so that you can factor out a negative and then add them. Okay, and here's why. All right, here's what we're going to get. Okay, so I've got log base b, x to the 1/4 power is really just the 4th root of x. Okay, minus, this is going to be log base b of 5 squared, which is just 25. So let's do log base b of 25 times y to the 10th. Okay, and that's what I've got. Okay, so I've condensed this. I've turned this into a single logarithm here. Okay, and done that part first. Now when I subtract, here's what we'll get. All right, we're going to do this up here. So we're going to get log base b, all right, of the 4th root of x divided by 25 times y to the 10th. Okay, and that is my single logarithm. Okay, and we can't go any further than that. All right, that one's tricky, okay, but that one's really important that we went over that because this step from here to here is crucial, and that's what makes it a little bit simpler, okay. All right, now let's do common logs, okay, to evaluate this log. Now, to answer this question, all right, so 7 to the what power gives us 2,506, okay? And that we don't know, okay? So what we would do, all right, to evaluate this log is I would do log of 2,506 divided by log of 7. Now, this is what I just simply type into my calculator, okay? And especially on your graphing calculators, how they just have that log button, okay? So they don't have a base button when you do logs, okay? So that you have to do change of base in order to evaluate these. So log of 2,506, all right, divided by log of 7, and that's going to give me a value of 4.0219, okay? I went to a lot of decimal places. That's because that decimal kind of keeps going on for a while. Depending on, usually we do 3, but, it doesn't really matter too much at this point. I'll let you guys know more specifics, on the homework and such as. So I hope you enjoyed this video. Hopefully this stuff makes sense. This will make a lot of sense when we start solving equations in the next section. So I hope you enjoyed this video. We'll talk to you soon. Thanks a lot. Bye.